Here today to tell us about creative computers is Dale Watson. Dale Lane. I'm sorry, Dan. That's all right.
Good morning. So this morning I would like us to think about this question. Can computers be creative? Now I'm going to tell you about a project that I hope will give you some insight into this. But first, before we can talk about whether or not computers can be creative, we need to agree on what we mean by creativity. Now there are different opinions on this, but if we look to psychology, in his book Explaining Creativity, Sawyer writes that creativity needs two things, novelty and quality. It's about coming up with something that is new and something that is good. And these two properties of novelty and quality are common in a lot of descriptions of creativity. But that still leaves us needing how we can assess whether or not a computer has been creative. And there are lots of opinions here too. A lot of them are similar to something you might be familiar with called the Turing test. Essentially what we do is we get a computer to produce some creative work, and then if we can trick people into thinking that it was done by a person, then the computer must have been creative. Now a common criticism with these kinds of approaches is that they tend to encourage mimicry of existing work rather than encouraging new and genuinely creative output. But that said, I do think there is something to be said for thinking about creativity as that relationship between the creator and the observer. Because a lot of psychology research on creativity does talk about how creativity is only meaningful in the presence of an audience that's perceiving the creation. That creativity can't exist in a vacuum. Creativity is sometimes described as a social construct, and that makes sense to me because we all perceive creative works differently. What might seem creative to me or novel to me might seem familiar or even boring to you. An approach that I quite like is the consensual assessment technique, and this is based on the idea that experts in a particular creative domain tend to be the best judge. If you can get that combined consensus from experts in a particular field, that is how you can tell if something's creative. So you assemble this panel of expert judges and you ask them to rate something that a computer has made without trying to hide any context from them or trying to trick them that it was done by a person. So lots of opinions on what we mean by creativity and different approaches for how we can assess if a computer has done it. But what I want to talk to you this morning about is a project that explored what it means for a computer to be creative. The project was called Chef Watson, and in this project, a team set out to build a computer that could create new meals and new dishes, new recipes. Not a search engine across existing recipes, but something that could create new and previously untried meals. So, before you can build a creative computer, you need to have some understanding of the creative process. And it's easy to just focus on generating ideas, but creativity is more than just that. You also need to be able to filter the ideas that you generate, to evaluate them, to be able to select the best, the most truly creative. So what does evaluating mean in this context? Well, what it means is that not only did Chef Watson need to generate ideas for new meals, new recipes, new dishes, it needed to be able to evaluate them, to select the ones that were the most creative. And as I said, if we think of creativity as being about novelty and quality, what we're talking about is filtering based on how new an idea is and how good it is. So for novelty, we're talking about recipes that are unusual, preferring recipes that are different, recipes that are surprising, recipes that have some kind of wow factor. For quality, we're talking about pleasantness, evaluating the pleasantness of the flavors, the enjoyment that someone would get from eating a new meal. But even those two steps aren't enough. The creative process is more than just these two stages. In fact, if I go back to Sawyer's book, he includes a description of the creative process in there. The first step, according to Sawyer, is to define the problem that you want to solve. Secondly, once you've defined your problem, you need to learn everything that you can about it, gather all of the past creative output. Now this provides inspiration, it tells you what's possible, and also if you don't know what's been done before, you won't be able to judge novelty. After that, he talks about how it's important to gather related information from a variety of other fields and other disciplines. The idea is to help you make new connections and new insights. After incubation, you're ready to generate ideas. And like I said, this individual step is often described as creativity, but Sawyer frames it as just one stage in the overall creative process. Next, combining ideas. Now, there is creative value in combining, in remixes, in mashups, in merging ideas from different areas. And as I was saying before, just generating the ideas isn't sufficient. You need to be able to filter them, to select the best and the most creative. And finally, successful creation isn't just the idea, but the execution of that idea. So Sawyer writes, he describes this final stage as externalizing the idea, even if that's just coming up with a plan for how you would turn that idea into something real. So this is the creative process that the Chef Watson team wanted to bring to computational cookery. So the goal was to build a computer system, a system that could learn the culinary traditions from recipes and from meals that have already been created. A system that could combine knowledge from other disciplines like psychology of people's likes and dislikes and the molecular chemistry of food ingredients. And finally, the goal was to build a system that could create new meals and new dishes, meals that would surprise you and that you'd enjoy eating. Now, the creative process that I talked about before was reflected in the ways that the project was shared and described, but more interestingly, it was reflected in the design and the technical architecture. Let me show you what I mean. Firstly, the stage of acquiring knowledge, all that past creative output. So the system built a food knowledge database that it populated from a variety of sources. Now, recipes were a big part of this. The system takes the text from a massive number of recipes and applies a variety of natural language processing techniques. Now, the component that does this is called the dish learner, and its job is to learn about dishes. It has to find all of the ingredients mentioned in the text. It has to identify all of the steps and the actions described in the recipe text. And more than just finding them, it needs to look for patterns in how they're used. What it's looking for is patterns in what it is that makes a stew, what types of ingredients are commonly found in certain dishes, what steps and actions are commonly found in meals from certain cuisines. The next step is when Sawyer talks about gathering related information to support the creative goal. And that was reflected in the database, which wasn't just about recipes. It included a wide variety of related information from other sources. And a big part of this included information about ingredients at the molecular level. So that meant detailed chemical information about ingredient compounds. Now, this was useful for a few reasons. Let me tell you why. You may recognize this guy. It's the chef, Heston Blumenthal. And one of his books is called The Big Fat Duck Cookbook. And in it, he talks about flavor pairing. This idea that culinary ingredients that share common chemical flavor components tend to combine well to produce pleasant dishes. He writes about being surprised that caviar and white chocolate go well together and how he investigated the underlying chemistry that makes it a good pairing. More recently, this flavor pairing pattern has been shown in several pieces of research to be actually a basis for modern Western cuisine. So, a molecular chemical description of ingredients combined with a psychological representation of what pairings people like and what they don't like. That's the kind of related information that was added to the database. And actually, it's worth mentioning, references to flavor pairings came up from the chefs that worked with IBM to develop the system. Chefs at the Institute of Culinary Education talk about thinking in terms of ingredient pairs or triplets when they're coming up with new recipes. Now, maybe they're not explicitly reasoning about chemistry, but it's analogous. They're drawing on their mental databases of flavors and combinations to model new meals. And they tell us that most professional chefs can reason about combinations of pairs of ingredients, and so that some of the best chefs can reason about maybe the combination of 3 flavors. But they tell us that probably no one can reason about 4 or more. I said that the next stage is generating ideas. Now, there are a few steps here. The system has to gather some requirements and specifications from the user. So it has to ask what ingredients they'd like to include, any ingredients they don't like and they'd particularly like to exclude, what type of dish they want, like, say, a stew or a soup or so on, and what cuisines they'd like the dish to be influenced by. So those requirements are combined with the requirements identified by the dish learner. That was that bit I mentioned before, that learns from the recipes that were fed into the system first. So maybe the dish learner had learned that for a particular type of meal, it's most common to have 1 or 2 types of meat, 1 type of fish, 2 or 3 types of vegetable, and so on. From the food knowledge database, it's able to identify all of the possible ingredients that it's identified in the recipes that meet these requirements, these constraints. And then from there, it's able to generate all of the possible combinations of ingredients and steps and actions that meet these requirements. And that's the requirements of what the user wants, but also the requirements of what is expected for this type of meal and this type of cuisine, based on what the system has learnt from the recipes. And when I say all the possible combinations, there are a lot. I'm not even talking about millions, it's more often quintillions. And a quintillion is a 1 followed by 18 zeros. Next, I mentioned combining ideas. Now, I'll come back to this later, but the system can generate some new ideas by combining and remixing recipes in its database. Next, selecting new ideas, evaluating the ideas to select the ones with the best creative merit. Now, as I said, I've already talked about this being assessments based on novelty and quality. Starting with novelty, I'll borrow an example from a colleague of mine. You hopefully agree that peanut butter and bread can go together. You probably think it's okay to put mustard on a hot dog because you've got a set of beliefs and expectations about various recipes, and that is based on what combinations you think tastes good, but it's also heavily influenced by the tastes and the meals and the foods that you've had before. You probably wouldn't expect to put peanut butter on a hot dog. That might clash with your beliefs. It might clash with your expectations. That might make it surprising. That's the idea that we try to use here. In the same way that, putting peanut butter on bread wouldn't surprise you. That it wouldn't clash with your expectations. It wouldn't change your beliefs, which makes it an uncreative thing to do. So Chef Watson uses this idea. It tries to model a set of beliefs before and after trying a new recipe. The technique used to do this is called Bayesian surprise, and it models that representation of a worldview of recipes before and after you've tried a new meal. And the greater the change in beliefs between those two states, the greater the novelty and hopefully the greater the creativity of the dish. Secondly, I mentioned pleasantness. The other assessments are based on pleasantness of the meals. And partly this is about the odor, the smell. So using the chemical flavor compounds I mentioned before, the system is able to model, to predict what that combination will smell like. And odor is a really key component of our enjoyment of a meal. The other assessments are about taste. And this comes back to the flavor pairing idea I talked about before. This graph shows combinations of flavors plotted on a graph across a couple of axes. Along the x-axis is a representation, an encoding of the chemical representation of that pairing. So it's combining things like the atom count, the compound complexity, the surface count, and so on. And on the y-axis is a representation of the psychological pleasantness. And that's taken by getting a large number of people to rate what they think of combinations of ingredients. And you find a correlation, and the correlation shows that it's possible to train a system by getting a large number of people to rate what they think of a large number of combinations of flavors, and then use that to predict what they would think of a new combination. Finally, externalizing the new ideas, turning it into a plan. This is a screenshot from one of the first versions of the system, and it shows how the system would take those ingredients and steps and actions that it had identified, found in the recipes, and then selected as being the most creative, and arranged it into a plan. Now, to be fair, it is telling you what to do with what, and it's got some sort of sequence, but it isn't what I'd call a recipe back then, because it still leaves a lot to the user to identify stuff like quantities and to flesh out more in detail about the step. So to sum up, collect a lot of recipes to build up an inspiration set. A dish learner component had to build a usable knowledge database from those documents, those recipes, and combine it with information from other sources, such as psychology and chemistry. A designer component that had to identify new combinations of steps and ingredients. An assessor that had to evaluate each new combination based on novelty, based on surprise, based on pleasantness. And finally, the planner that took that combination of ingredients and steps and turned it into that kind of recipe plan that I showed you before. So this was the design. Let me show you what it looked like. This was the first version of the system. Now, the first thing I need to do is to choose an ingredient, my starting ingredient that I do in the top right there. Once I've done that, the system identifies the cuisines that it's learnt from the recipes commonly include this starting ingredient. Once I choose a cuisine, it then identifies, it comes up with that list on the right of dishes. Dishes that it's learnt are commonly found in that cuisine with that starting ingredient. So as I make changes, like say if I choose a different cuisine, the list of dishes changes. And actually I can make it a bit more complicated by choosing multiple cuisines if I want it. Once I've chosen my dish, the system starts to identify a few sets of common requirements that it's inferred from the recipes. And if I scroll down a bit further, you might be able to see that number. It's saying that over 9 quintillion possible combinations of ingredients and steps can be made out of the criteria that I've specified so far. And underneath that, you can see what I was talking about before. The dish learner has identified that based on the recipes that it's seen, meeting this initial criteria, it's seen that most commonly it would expect to see between 1 and 2 types of cheese, between 1 and 4 types of vegetable, and so on. So next, it's made its choices for the sets of ingredients, and it's showing me a summary of them, together with some rough indication of the assessment of the novelty, the surprise, and the pleasantness. So as I choose, those dials update, but also I'm shown this representation of the combination underneath. If I scroll down, I can see the starting ingredient that I picked and the cuisine that I asked for it to be influenced by, and it's showing the association between my choices and all of the ingredients that the system has chosen. And the thickness of the line shows how commonly it's found that association in the recipes in its database. And this can get quite complicated. This is showing where I'd chosen apple as my starting ingredient and asked for influences from a combination of 4 different cuisines. And if I really want to, I can drill down and see some of the evaluations of the individual flavor pairings and see the combinations that the system thinks are particularly effective or that might have a negative effect on the dish. And then obviously the next step, as I mentioned before, was turning that into a plan. So this was the first version of Chef Watson, really useful to chefs, or at least enthusiastic experts. But in particular, the externalizing step left a lot to the user, who had to figure out quantities and detailed instructions. And that was a real driver for the next version. What we wanted was to turn this into a system that could be used by anyone. So if I jump forward, this is version 2. Now it's still reasonably constrained. You still have to choose from lists of ingredients and dishes and cuisine types that the system has learnt about from its recipes. But you can choose how you want to trade off that balance between novelty and quality, shown here as this scale between classic and unique. But actually, quickly going back, one important thing to notice, we now have quantities, we now have detailed descriptions. Now, to be able to come up with proper instructions, it meant we needed a new component in the system. After generating that combination of ingredients and actions, Chef Watson would have to look through its database for existing recipes that had similar steps and similar patterns. The new component that did this was called the Dynamic Planner, and its job was to look for possible template recipes in its database that it could use as a starting point. And when I say templates, I don't mean tweaking 1 or 2 attributes. It would be making hundreds of modifications across the large number of templates that it found, modifying them, remixing them, making changes like adjusting ingredients, changing proportions, changing cooking times, and so on. Jumping forward again, this is the third version of the system. A key thing to notice here is that now you're not choosing from a list. You can type in freeform anything that you want. Now, as you type in, underneath you can see the system's offering some suggestions for things that might pair well. And also, you can see this list of recipes on the right. So as I make my selections, as I type, this list on the right updates with ideas. And again, I can choose how I want to balance quality, novelty versus pleasantness. Jumping forward one last time, this is what Chef Watson looks like today. The workflow has changed here. What we're focusing on here is letting you play with combining combinations of flavors. And it comes back to what I was saying that we learnt from the chefs before, that probably people can't really mentally model combinations of 3 or more flavors. So that's what this tool is enabling them to do. So I can type in an ingredient that I want, and after I've typed in my first, the system suggested a few things that might go well with it. But if there's any of those that I don't like, I click on the cross and remove them. And actually, I can type into any of the other 3 boxes if I want to suggest a second or third or fourth ingredient. I can still choose the type of dish I want using a menu that slides in from the left. I can choose what kinds of cuisines I want the system to be influenced by. And you can see as I make all of these suggestions, the recipes at the bottom are updating as it's coming up with new ideas. And if I click into any of these, I get a detailed recipe with steps, with quantities, with directions. And that's the point. Chef Watson is now able to come up with recipes, new recipes that can be followed by a non-professional. So I'll sum up. Gathering knowledge, massive numbers of recipes, and using that to build a food knowledge database, a data-driven model to enable creativity. And after that, the components in the system closely follow the stages of the creative process as described by Sawyer. I've tried to show the different approaches that the project took over the years, as we've found that different use cases, different users are better suited by different approaches and different algorithms. Because you might want, the role of the computer in the creative process should vary depending on who it's for and what they're trying to do. You might want the computer to be entirely autonomous, or you might want the computer to be some sort of assistant or coach. So if I go back to my question, can computers be creative? Is Chef Watson creative? Now it is creating new meals, meals that taste good and are genuinely novel. So do you think that's creative? It was people who decided on the problem to be solved, who chose the sources to use for the system's database, who chose the factors that the system should use to evaluate and rank. All of those decisions were as important a part of the creative process as the computer's automated application of them. So the computer isn't necessarily doing all of these steps, but I don't think it has to, because the computer is making a significant contribution here. I think that this is a project that demonstrates the chefs and the technologists and the computers coming together in shared pursuit of a creative goal. And in that, like with other similar projects, I think it shows that computers can be creative. But I think it also shows that we still have a long way to go to be able to build computers that can own more or even all of this creative process by themselves. And with that, thank you very much for listening.
Ladies and gentlemen, Dale, thank you very much. We have